Okay, example 4 from 3.3, and it's been noted that the homework assignment for 3.3 day 1 and 3.3 day 2 are the same assignment. So I'm going to make 3.3 day 2 due on Wednesday. Alright, and those of you aren't going to be here Wednesday. Hopefully you'll be here part of the day Thursday. In fact, I think you'll get back before school's over Thursday. You should bring it to me Thursday, that'd be fine. Anyway, differentiate f of x equals 6x to the pi plus 3x to the, or 3 pi to the third minus ax to the fifth. The point of this problem is to focus on structure when you're differentiating. The power rule is the one we want to use, the one that says f of x is equal to x to the n power, then f prime of x is equal to n x to the n minus 1. Okay? What I want you to really focus on with this power rule is the structure of the term that's being differentiated. X raised to a power. It's not something over x raised to a power. It's not x times x. It's just 1x raised to a power. If it has anything in front of it, if it has an a in front of it, then it's a n times x to the n minus 1. So any constant there's not going to really modify how you do it. It's just going to make a product down here instead of just a single number. If you take a look at this first term, 6x to the pi, that's the letter x and it's being raised to a power. The power is pi, but it's still pi as a number, so it's just got that structure, right? So the derivative of 6x to the pi power, f prime, oops, I didn't put a prime on, f prime of x equals, you do pi times 6 is 6 pi, and then you subtract 1 from pi, which, as far as I'm concerned, is pi minus 1. Alright? It doesn't look very friendly, but it uses the same rule. The rule states if this structure exists, that's how you differentiate. That's all I did to that term. Second term, 3 pi to the third. This says f of what?
X.
X. Is that an x?
No.
So 3 times pi to the third is equal to some number, right?
Cross out.
Derivative of a number is 0, right?
Mm-hmm.
Officially plus 0, you don't have to write it down. Alright? The next term, minus ax to the fifth. A is not x, it's a constant, so a is going to act like any number would act. X is the letter x being raised to a power, so it has this structure, which means I can multiply 5 times negative a makes negative 5a x, and then we reduce the power by 1. So 6 pi x to the pi minus 1 plus 0 minus 5a x to the fourth is the derivative. I would probably write my final answer without the plus 0. If you have proper structure, in other words, something times x to a power, you're ready to go. If you don't have proper structure, then you need to use algebra to modify the structure first and then apply the power rule. All right? Everything in this first assignment is going to use the power rule at some point, but a lot of the problems have to be modified before you can. And the next problem will really deal with that more than this one did.